We are deploying a large array of seismic sensor to do what is called a surface wave tomography. This array, you see one of the sensors here that has been just deployed, is a more or less regular grid that covers the whole area, and it will be left listening and measuring the seismic noise for a week. It collects data continuously. It collects the data coming from whatever source of noise that exists in nature or of anthropogenic nature, and also collects the data of the active sources that have been used along the active seismic lines. We are going to measure a particular seismic wave, which is called Rayleigh wave, and these waves have a particularity in their propagation. They travel along the free surface horizontally, and when we strike a source, we throw in the ground many different frequency components. Each frequency component creates a wavelength, and this wavelength travels through a layer which is more or less as thick as the wavelength itself. So the different wavelengths that belong in a way to the different frequency components of the signal sample different thickness of the subsurface, from few meters down to some 100 meters. The array have been designed in order to have good sampling of wavelengths down to 600 meters. It means that we would have reliable results down to 350, 400 meters.